C. Created in 1972 by Dennis Ritchie at Bell Labs, C is essentially the grandfather of modern computing. It was built to design the Unix operating system, and it succeeded because it is blindingly fast and gives programmers direct, uninhibited access to the computer's memory and hardware. Think of it as driving a manual sports car with the traction control completely turned off. There are no guardrails. If you make a typo, you can crash the entire system. But that raw, close to the metal power is exactly why it was used to build the foundations of Windows, Linux, and Mac OS. Almost every major language around today borrowed its syntax directly from C. It is the invisible bedrock holding up our digital world, proving that sometimes the old-school ways are still the most powerful. Java. Released by Sun Microsystems. In 1995, Java was built with one revolutionary slogan: write once, run anywhere. Before Java, software had to be custom compiled for every specific type of computer hardware. Java solved this by running inside a virtual machine, acting as a universal translator. This made it the immediate choice for massive corporate infrastructure, banking systems, and early mobile phones. It is also the original engine behind Minecraft, proving its capability to handle complex game worlds. While it is often criticized for being overly wordy and requiring a lot of lines of code to do simple tasks, its strict safety rules and extreme reliability make it an absolute tank for enterprise software. It remains one of the most widely used and financially dominant programming languages on the planet. C++. If C is a classic sports car, C++ is a heavily armored tank with a rocket booster attached. Created in 1983 by Bjarne Stroustrup, C++ took everything great about C and added object-oriented programming, allowing developers to manage massive, incredibly complex software systems much easier. Today, C++ is the undisputed king of high-performance software. If you've ever played a massive AAA video game running on Unreal Engine or edited media inside a heavy professional desktop application, you are witnessing C++ in action. It allows developers to squeeze every single ounce of performance out of high-end GPUs and CPUs. The catch? It is notoriously difficult to master. It requires you to manually manage your own system memory, and a single mistake can cause massive performance leaks. It's brutal to learn, but for raw speed, nothing touches it. Assembly. Assembly isn't just one language. It is a family of languages that represents the absolute closest a human can get to talking directly to a computer's processor. Instead of abstract, English-like commands, assembly uses cryptic, low-level instructions to move raw data directly between CPU registers and memory addresses. Writing a simple program in assembly requires hundreds of lines of meticulously detailed code, making it incredibly slow and tedious for humans to write. However, because there is no abstraction layer, assembly code executes with the absolute maximum speed and efficiency possible on physical hardware. Today, it is used for writing critical low-level code like operating system kernels, hardware device drivers, and reverse engineering complex software. It is the ultimate tool for developers who need absolute total control over the machine. Python. Released in 1991 by Guido van Rossum, Python was designed with one core philosophy: absolute readability. It throws away the confusing brackets and complex syntax of older languages and replaces them with clean, English-like commands. It's so simple that a beginner can write a functional script on day one. But don't let that simplicity fool you. Python is incredibly powerful. It has become the undisputed champion of data science, automation, and artificial intelligence. When you see modern AI models learning, analyzing massive datasets, or generating automated content, Python is almost always running the show behind the curtain. It is slightly slower than languages like C++ because it requires an interpreter to translate the code, but the sheer speed at which humans can write it makes it a modern developer cheat code. JavaScript. Released in 1995, Brendan Eich famously built the very first version of JavaScript in just 10 days for the Netscape browser. Initially, it was just a simple tool to make static web pages a little more interactive with basic pop-ups and drop-down menus, but then the internet exploded. Today, JavaScript runs natively on nearly 99% of all websites on Earth. Thanks to modern frameworks, it expanded from just controlling your browser to running massive server backends and mobile applications. It's a notoriously quirky language with some bizarre logic flaws under the hood, but its sheer scaling capability means it cannot be killed. If you are looking at a screen right now that connects to the web, you are interacting with JavaScript. It is the messy, unkillable engine of the World Wide Web. Lua. Created in Brazil in 1993, Lua was built to be a lightweight, highly embeddable scripting language. Instead of trying to run an entire operating system by itself, Lua is designed to sit comfortably inside a larger program written in C or C++ and handle the internal logic. Because it handles data tables, fast iterations, and server-side scripts with insane efficiency, it became the technical backbone of massive gaming platforms like Roblox, World of Warcraft, and Garry's Mod. It allows developers to completely change how a game behaves, manage complex custom user interfaces, or handle secure user data persistence on the fly without rewriting the core engine. It is fast, memory efficient, and elegant, proving that a programming language doesn't need to be massive to completely dominate an entire industry. Rust. Released by Mozilla. In 2010, Rust was specifically engineered to solve the ultimate programming paradox. How do you get the blazing fast performance of C++ without the dangerous system crashes and security bugs? Rust achieves this through something called a borrow checker, a built-in system that strictly enforces memory safety before the code even runs. If your script has a hidden flaw that could cause a crash or a vulnerability, Rust simply refuses to compile it until you fix it. It's like having a hyper-strict editor looking over your shoulder. Because it delivers elite speed without the danger, tech giants are rapidly using it to rewrite core parts of cloud architecture, infrastructure, and operating systems. It is the future of safe, high-performance systems programming.